So in this video, we're going to build upon our lesson from yesterday to solve a system of inequalities. And we'll determine where the solution is found. You saw yesterday that when you graph an inequality, there's some shading that represents a solution, because there's many solutions to an inequality. So today we're going to build on that to a system of inequalities. You probably saw this yesterday. If you didn't get a chance to copy it down yesterday, take a minute and do so now. And it's very important to be able to understand these concepts. All right, so here's what a problem would look like. We want to graph this system of inequalities. So what I find is that it's best to do them in the y equals mx plus b form. So what I'll do is I'm going to start with the line y is less than 3x plus 4. I'm going to identify its slope as 3. If you want to write it as a fraction, 3 over 1. So it's rise 3, run 1, up 3 over 1. The b value is 4. That's all pretty old school stuff. We've done that before. But now we got to talk about, is the line going to be solid or dotted, and which way do we shade it? So because it's a y is less than, it's going to be a dotted line or a dashed line. And because it's less, the y's are less as you go towards the bottom of the graph. So we're going to shade this one down. So if I plot a couple points here, I'll start at my y-intercept. I'll go up 3 over 1, up 3 over 1. Let's continue to the left side by going down 3 left 1, down 3 left 1, down 3 left 1, and so on. Again, it's a dotted line, so we're really just making a boundary here. Now, if during your work you actually make your dotted line solid, please don't go over it by saying, well, I meant it to be a dotted line. No, just redo it. Just redo it. And we shade this down, so I'm going to shade towards the lower side of the graph. So I'll shade down this way. We need to throw a label on it. So y is less than 3x plus 4. Things look good. Let's switch over to green for the other one. Negative 3x minus 2y is less than or equal to 6. Again, let's put that in y equals mx plus b form. I'm going to move my 3x to the other side. And let's write it in the y equals mx plus b form by putting my 3x term first. And then I'm going to divide by negative 2. And notice that when you divide everything by negative 2, regardless of whether or not on the right side you have two fractions, or if you combine it all and just write it as a big fraction or something like that, I think you want to recognize that we divided by a negative. So we got to switch the direction of the inequality. So now it's a y is greater than or equal to. We divided by negative 2. Same things as before. Our slope is negative 3 over 2. Our y-intercept is negative 3. And again, how are we going to shade this? What's this line going to look like? Because it's a greater than or equal to, it's a solid line. And because it's a greater than, we're going to shade this one up. So let me go to my y-intercept of negative 3. I'm going to go down 3 to the right 2, down 3 to the right 2. Other direction, up 3 to the left 2. This is a solid line, so I'm going to make it a solid line there. You'll use a ruler. You'll be better than me. And we're shading it up. Is it okay that they're overlapping? We'll talk about that in a moment. We'll talk about that overlap in a moment. Oh, I need a label on here. Negative 3x minus 2y is less than or equal to 6. Great. So please take a moment. Make sure that you've shown the same work I have. You've shown your y equals form. You identified the slope and y-intercept. Shaded your lines, labeled. All should look good. Now, you did notice that it was shaded twice. The solution, or a solution, is any point that's in that double shaded area. So we want to name a point that's in the solution set. what are the coordinates of a point that make both inequalities true? Well, let's go back and find something in the double shaded area. Yes, there's 1,000 points, 2,000 points. See this one right here? That's not one of them. Don't choose that one. That's not a solution because that would lie on the dotted line. Remember, the dotted line is not a solution. It's like a boundary line. So pick one way off in the area. I like to pick maybe this point right here. It looks like its coordinates are x equals 1, 2, 3, 4, 5, 4. So the point 5, 4 is one of many points in my solution set. Just find one that's shaded twice. And we'll indeed say that that is one of many. So we're just going to build upon our work from yesterday a little bit. Now, you might be saying, I got this beautiful calculator here. Can I do this on the calculator? Yes, you can. Step one is just to put them in their, quote, y equals form, their y equals mx plus b form. So then what you're going to do when you get to the calculator in step 2 and step 3 is, once you get to step 3, delete the equal sign, and you're going to have a whole bunch of options that show up. It's going to look things like this, like 1 is less than or equal to. Press 2 for less than. Press 3 for not equal to. 4 is greater than or equal to. 5 is greater than. It looks something like that. Choose the appropriate sign. And then just repeat it. So why don't you try that on the calculator? First, put them in their y equals mx plus b form. The bottom one's already there for you. When you press graph and you press tab to get the entry line up, just delete the equal sign and choose the right expression. When you do that, did your graph look something like this? A couple things you can see here. First of all, can you tell that this line is a dotted line? The calculator will make it dotted for you. The other line is solid. And can you also tell while this green region is shaded a little bit lighter, this green, they're kind of shaded the same, but this region here in red, see how that region is shaded darker? That's where your solution set's located. So we want to pick a point in that solution set. Maybe if you go over, let's see, to 1, 2, 3, 4, 5, 6, 7, 8. If I go to where x equals 8, hey, how about that point? 8, 0, that works. That makes it true. So in this video, you should have learned that you can graph two inequalities on the same line, and you could determine the point that's in the double shaded region. That's our solution set. And if you want to use the calculator, use the calculator. It's pretty cool.